So a structure that can come up in word problems deals with linear equations. So linear equations have a very specific format that they follow, and when we model with information or data, there's kind of two pieces that we need to find for our equation, and what we're going to do is practice the different ways that we can form that. So a linear equation, we're going to look at this y equals, and then one of our not one of our variables, but one of our features is going to be something we'll call m, and then x plus, and then something we'll call b. So when we make our equations, we're going to have numbers input there for m and b, and then y and x are going to be our variables. So those letters might change as we go through different, like here we're going to deal with T and Q, here we're going to look at C and Q, but the idea here is that we call Y the output, something that we're outputting from our equation, and then X is some input. So our linear equation is going to have this format. Now let's talk about M and B. So in terms of a linear equation, this represents the slope, or it can be thought of as the rate of change. So some examples for M, especially in terms of word problems, so it's going to be a rate. So what that could come through as is like miles per hour. That's a rate at which our car travels. It could be dollars per minute. Maybe that's the cost of using a payphone or something like that. So when we have slope, this word per or each is another word that can come up. So dollars each minute. Those are going to relate to our slope, our rate of change. So it's how our equation's changing as our input changes. Now our other value is b. And in math, we call this the Y-intercept. But in terms of word problems, how we could think of this is the initial value, because it's basically what happens when x is 0. This is our value. When x is equal to 0, this is our output. So often if x is 0, that's at the beginning of time or the beginning of traveling. So we'll talk about some different ways that these come through in our word problems here, but with M, and this ties back to our algebra skills a bit, there are ways of calculating M, and there's a few different ways to think about it. One is thinking of change in output over change in input. So how is y changing compared to how x changes? Another way we can think of slope is if we think of having two coordinates. So if we have some x coordinate and some y coordinate, and then a second x coordinate and a second y coordinate, in the numerator, we're taking a difference of those y coordinates. So I'm going to write this as y2 minus y1. And then in the denominator, to look at the change in x, we would take x2 minus x1. So sometimes they may give us wording that directly gives us our slope. Sometimes they'll give us these kind of an idea of two coordinates, and then we'll need to calculate the slope. So let's look at some examples here and see how this is coming through. So to start producing a new model of custom wheels, a company will have to purchase $30,000 in new equipment. And I'm just going to highlight that $30,000. Each wheel made costs them $40 in supplies and labor. And something I want to highlight there is that they said the word each. So each wheel costs them $40. So write a formula for the total cost T of producing Q wheels. And then we're going to calculate what will be their total cost in the first year. Let's save that question until after we form our actual linear model here. Okay, so what we're focusing on here is, so T is total cost. I'm just going to write down these variables. So T is total cost. Q is the number of wheels. Q is for quantity, so quantity of wheels. And then we have two other pieces of information. So what we do is we have this $30,000 cost for the new equipment. So I'm just going to write down $30,000 for the new equipment. And then there's this cost in supplies and labor, and it's $40 per wheel, or for each wheel, there's a cost. All right, so these two things together are making up this total cost for producing the wheels. So overall, they had to pay $30,000. And that's not going to change. Then they only have to pay it once. They just need to pay for this new equipment once. So in terms of costs, this is their initial cost. This is what they're starting with. So if I start to make my equation here, so we're calculating total cost, and that's going to equal, and I'm going to go ahead and write down the 30,000 first. So this is going to be my value for B. In fact, I'll write it in red to match up above there. So we have this fixed cost of $30,000. That's another way we can think about B is as the initial value, or you can think of it as a fixed cost, whereas slope is called a variable cost because it's changing. So we'd pay that $30,000, and then we're going to add on this variable cost, this $40 per wheel. Now, if we think about how this is going to behave, okay, if we produce one wheel, we need to add on a cost of $40. If we produce two wheels, we would need to add on a cost of $80. Three wheels, $120. So as we increase the number of wheels that we're producing, that variable cost is changing. So it's depending on what we have for Q here. So to have this $40 per wheel, how I'm going to write this is we have the 40, and then we're going to multiply that by whatever Q is. So my model ends up being T equals 30,000 plus 40Q. Or if you want it to match the format up above, you could have this as T equals 40Q plus 30,000. But the idea is that we have this fixed value, so this initial cost of $30,000, and then this rate of change, this $40 per wheel, that's going to end up being $40 per, and then that per can be thought of as multiplication with Q. We'll get a lot more practice with these two. So we made our model, and now we want to know what will be their total cost in the first year if they expect to sell 240 wheels. So what we're doing here is we're letting Q equal 240. So I'm going to go to our equation and go T equals 30,000 plus 40 times 240. And we could just plug that into a calculator. So 30,000 plus 40 times 240. And that is $39,600. So their total cost, if they expect to sell 240 wheels, would be $39,600. And then we could just plug in different values for the number of wheels and find different total costs. So with that one, they gave us the numbers directly for what that slope is and what that y-intercept is. Or in terms of y equals mx plus b, they gave us m, they gave us b, where b was this fixed cost and m was described as a variable cost. Let's look at another scenario here. So we have the balance in your college payment account, C, is a function of the number of quarters you attend. Interpret the function 20,000 minus 4,000 Q in words. So C equals 20,000 minus 4,000 Q. So the slope is always going to be multiplying our input variable. So this negative 4,000, that's our rate of change. And this value of 20,000, this is our initial value. And then if it helps, we can say, so C is the account balance. And then Q is the number of quarters. So if we have this initial value of 20,000, what that's representing is, so in the last example, it came through as a fixed cost. But again, this idea of initial value is like, where is our output starting? So our account balance is starting at $20,000. So this is telling me the starting balance of the account is $20,000. All right, then we have this slope that's a negative 4,000. So with this, we have a negative number here, and the positive and negative of our slope tells us whether our output is increasing or decreasing. So in number one, what we had was this positive 40. It's because the cost was increasing by $40 per wheel. In fact, I'll make a note of that cost was increasing by $40 per wheel. So, and then in terms of units, like having 40, and this idea of dollars per wheel, what we could do is think of that as a fraction. We have our dollars in the numerator, the divisions like per, and then wheel would be in the denominator. So if we think of units like this, it's coming from the units that are the output over the units for the input, because how we calculate slope comes from change in output over change in input. So with this one, what I'm seeing here, and maybe I'll make myself some notes to the side, but with that negative, what that's telling me is that the output, so the account balance is decreasing. The account balance is decreasing by, and then this 4,000, if we want to think about the units that we have for this 4,000, we could set up that fraction for the units, and we want to take the units for the output, which in this case is C, so that's dollars, divided by the units for the input, which was the number of quarters. So this is going to be like dollars per quarter. So what this is telling me is that the account balance is decreasing by $4,000 per quarter. So let's put this together. In terms of an account that's paying for someone's college, they started with $20,000 in their account, and basically they're withdrawing $4,000 each term or each quarter in order to pay for their classes and things like that. So the starting balance of the account is $20,000, and then that balance is decreasing by $4,000 per quarter. So how many quarters of college can you pay for until this account is empty? So what this is asking is, when will the balance be zero? So we want to look at this when C is equal to 0. So we're solving 0 equals 20,000 minus 4,000 Q. So add 4,000 to both sides. Sorry, add 4,000 Q to both sides. Divide by 4,000, and we're going to see Q equals 5. So they can pay for 5 quarters of school with this account. Okay, one more here. So working as an insurance salesperson, Maria earns a base salary and a commission on each new policy. So Maria's weekly income, I, depends on the number of new policies, N, that she sells during the week. So let's go ahead and write down these variables. So capital I is going to represent the weekly income. And N is going to represent the number of new policies. Okay, so last week, she sold 3 new policies and earned $760 for that week. So we are getting this relationship between, sorry, 1 second. Okay. So this is one scenario of like N equals 3 and I equals 760. So that's one kind of grouping that we have. And then the week before, she sold 5 new policies and earned $920. So another scenario is N equals 5, and that made I equal 920. So find an equation for I and interpret the meaning of the components of the equation. So we want to fit, this is going to be a linear equation, that's what we're focusing on here. So we want I equals, and we're going to have some rate of change times our input variable, which is going to be the number of new policies that they sell, plus that Y-intercept, or that initial value. Okay, so we want to find M and we want to find B. We're going to start with finding M, mostly because they didn't tell us the initial value. Like, they didn't tell us what happens when N is equal to 0. So they didn't tell us what Maria earns if she doesn't sell any new policies. Like, they don't say anything about her base income or anything like that. So what we want to do is, this is a scenario where they're essentially giving us 2 coordinates. Like I was saying up above here with our different ways of thinking of slope, this is a case where they're giving us 2 coordinates and we think of them as x, y. In our case, N is the input, so that's kind of being treated as our x value, and then I is our output, so that would be treated as our output value, y value. So how I'm going to write these coordinates is 3, 760. And 5, 920. So calculating slope, what we're going to do is take the difference in outputs over difference in inputs. Order doesn't matter in terms of which is 1 and which is 2. So let's say I call 3 x1 and 760 y1, and then 5 can be x2 and 920 could be y2. So what I'm going to do is take y2 minus y1 over x2 minus x1. So that's the equivalent of 920 minus 760 over 5 minus 3. And then we'll get that from the calculator. So that is going to be positive 80. So we have a slope or rate of change of 80. So in terms of my equation, I now know I have I equals 80 times N plus, but we still don't know what B is. However, what I can do is I can solve for B. So this is going to be our second step, is what we're going to do is plug in a coordinate. So in this case, our coordinates are using N and I. So we have 2 coordinates. We have this 3, 760, and we have this 5, 920, and I just need to choose one of them. Doesn't matter which one. I'm gonna go with the 3, 760. No particular reason, I'm just gonna use that. So again, the 3 is N and the 760 is I, so I'm gonna go 760 equals 80 times 3, and then plus B. And then I can multiply the 80 and 3 together. subtract 240 from both sides to get 520 is equal to B. So we end up with our equation I equals 80 times N, and then our initial value is a positive 520. So this tells me, so we got this information from two scenarios with a certain number of policies and a certain income, and then a different number of policies and a different income, but we could tell how the rate of change behaved, and then plugging in one of those coordinates or one of those scenarios, we could solve for that initial value. Then what this equation tells me overall is, so this 520 would be her base salary, and then her commission would be the $80. So what's happening is Maria earns $520 weekly as a base salary, and then for each new policy that she earns, she gets an extra $80 per policy. So if there were 3 policies, then we'd add that up to $760. If there were 5 policies, it would add up to $920. But now you can see what would happen if she sold 10 policies. How would that change her income and things like that? Okay, so we'll get a lot more practice in the next video too with these linear models, but it's fitting this y equals mx plus b that we learn about in math using linear equations. And what we're doing is just using word problems to kind of fit models to this format so that we can form these equations, interpret these equations, and then use them for different calculations.